Welcome to 330 Sustainable Manufacturing Systems. This is Lecture 7, Material Requirement Planning. Alright, so today we're mainly going to talk about the applications of MRP, what is the master production scheduling, and also how the MRP explosion works. Then next, I'm going to talk a little bit about ERP and also supply chain management. Alright, what is MRP? So MRP, sometimes you might heard that people might tell you that is the software for managing of the inventory, but in fact, MRP is a logic. It's a logic for determining the number of parts, components, and all materials needed to produce a product. For example, if your company received the order that I need to produce 1,000 TVs, then the MRP will help you to sort out how many of the parts, materials that are needed at a certain time in order to fill this order. All right, so next, the application of MRP. So it's not always that MRP is very useful to all the operations in manufacturing. It's mostly valuable to assembly operations because MRP mostly is dealing with the parts and different items and materials within a product. So if the part or if a product only has one or two parts, then in this case it probably does not really you do not really need an MRP system to deploy all these different parts at a certain time. Well, so that's why it's most valuable when a product has a lot of parts that involved in the processes on the shop floor. And so for fabrication processes, usually that is does not require a lot of external parts and also supplies. So that's why it probably least valuable to that. And also MRP is not so valuable to high producing complex expensive products requiring advanced research and design, because those kind of lead time are usually long and uncertain. And in MRP, mostly we are assuming that the products have a really constant or consistent lead time and always can arrive in a short time. All right, now in order to talk about MRP, first we need to know what is master production scheduling. So MPS means basically it's a scheduling overview. For example, in this example, it says in month 1 we need 900 matrices production. In month 2 we need 950. Well, then we can further decompose this 900 order into what different models do we need, right? Model 377 we need 200, and then model 538 we need 100. Then also we have some other 100 and 400 items. So this is give us a decomposition of different models that's needed within a bigger scope of 900 products that we need to produce over the whole month. Same with 950, that they can further decompose into different models for that. So the master production scheduling means we have a general idea about how many products we need to produce on the shop floor, and then decomposing into very specific models and specific parts that is can be scheduled on the shop floor or production line. All right, so MRP is really it starts from the customers, because those product requirements are really depends on what is the demand from the customers, right? And also specific orders. All right, in order for us to explode the MRP table or to generate the material resource planning, we first need to understand the bill of materials. We have learned that into 11 what is a bill of material. So basically, it is a product tree that what are what are the parts are composed at the different levels of the whole product. For example, product A is composed of 2 B's and three C's. So B and C are major, you can call it module or big parts. Then for each of the B, it can also be decomposed into 1D and 4E. So you need to pay attention. So for 1D and 4E, this is for 1B. Right? This is not for 2B's, it's for 1B. 1B is composed of 1D and 4E's. Similarly, so 1C is composed of 2F, 5G, and 4H. Right, so this is what it means. And here, 1A is composed of 2B's and 3C's. So this is what it means in the bill of material when we are looking at the numbers. Well, another way to look at the bill of material is, we can also list the parts at different levels. For example, this is called the indented parts list. So this means you can see there's only one at this column. So basically, this is the highest level, which is product A, and then at the second level here in this column, you can see 2 B's and 3 C's, and this column you can see under this 2 B's, right? Under this B, you can we have 1 D and 4 E's. So which means each B is composed of 1 D and 4 E's, and this means 1 C is composed of 2 F and 5 G's, and also we have H, right? 4 H. 2F, 5G, and 4H. Right. All right. So another way is we can also list the parts in a single level parts list. So single level part list means we only have 2 different levels. The one level is the bigger parts, right? The other level is decomposed parts. For example, A, you can see it's 2 B's and 3 C's. Then what about B? So B is composed of 1 D and 4 E's. And then what about C? C is composed of 2F, 5G, and 4H. If I'm saying if. So if H can be composed into another 2 parts, then we're also gonna list H here, right? Then what? So just if. All right, so this is another way to do bill materials, but in this class, usually we are using the product tree, more with this kind of product tree to show bill materials in MRP scheduling. All right, so when we are composing the product tree, we first need to know the hierarchy of the product, right? So, for example, in this case, the L in L is the final product, or the big component part, right? It is composed of M and N, and then M composed of P and N, and N is composed of Q and R. And in this way, and you can see there are 4 different levels: 0, 1, 2, 3, 4. Level 0 is always the final product. Okay, and so the graph to the left, you can see it's not very clean. So the reason it's not clean is because we can see N here. We have an N here. We also have an N, but N is the same part, right? Because it's the same part, the same number, but they are in 2 different levels. Sometimes they can get confused, especially when you are using computerized program or system. You won't have the same code or same number for the parts with the same name. So that's why a lot of time we're gonna put them into the same level, right? So currently you can see that this ends in level 1, this ends in level 2, but we want to put in the same. How do we put in the same level here? So that's why we created this low level coded BOM. So low level coded BOM means we want to make sure that all the same parts are on the same level. So if it is N, we want to N all in the same level, right? If it is R, we want to make sure all the R's are on the same level. If it is S, so all the S will be on the same level. Okay. All right. So now let's first look at N. In this original BOM, the one N is in level 1, one N is level 2, right? So there's no way to have move level 2 to level 1. So that's why we have to always move the higher level of the name of the parts, move to the lower level in order to be consistent with the other one, with the lower one, right? So that's why I move this N down here, right? To make sure that we have the two ends are at the same level. So that's why it's called low level coded BOM. Same with R's. So here you can see the left product tree, we have R level 3, R level 3, and one R level 2. So in this case, we have to move R to a lower level, make sure these three R's on the same level. Same with Q, and same with all the S. Same with all the S. Okay. All right. So one thing I need to emphasize is that when you are drawing this product tree, you have to make sure that you list all the parts in the product tree. What does it mean? It means, for example, you have the N here, right? So N you already deployed. Employ this, Q, R, and S, right? And someone may think, oh, I already showed that N is composed of these parts. And here we have another N. I don't have to, to do that again. But in fact, you will have to. You have to put all the details here, right? To draw another part of this, right? So if S, if Q is composed of S, then we also want to make sure that Q composed of S. Right, one Q requires one S. If R requires another part, of course we have list here as well. Right. So this is something you need to note that it is very important. Keep in mind that you still have to fill out all the other parts, even though you have already expanded this part. Alright, so this graph mainly shows how the MRP system works in this whole production system scheduling and also supplies. And so this is a master production schedule. Based on the master production schedule, we get a forecast or the demand from the MPS. Then the MRP will get information of the demand. Then based on the demand and also based on the bill of materials, we can deploy or start to explode the MRP to be to see what products or what parts will be required and at what time. Okay. Also, make sure another information we need to know is the inventory records file, because when we know that we need 1,000 TVs, right? We first want to look at what about the inventory level? Do we have already made TVs? Do we have some existing parts? And how many parts do we have? Then it will determine that how many parts we still need from our suppliers. Right, so this is how the MRP works with other functions of the production company. All right, now let's use one example to show how to complete a MRP table. So I want to explain that usually in production companies you do not have to do it manually. Usually there's a software will help you do that, but in this class, you need to understand the logic, right? You need to understand the logic, how the demands at different time of the product or parts are determined. Otherwise, it's hard to understand why we're doing it. Especially, in the future, what happens is if you're a production manager, for example, your company is trying to develop a software for your company, because a lot of times those kind of softwares are customized into your own situation. So you have to explain to the software development like how the logic works, because they do not know the logic, and you have to tell them or explain the logic. That's why you need to understand the logic and how it works. And this is why we are composing this MRP table manually. All right, so a company produces a line of electric P meters installed in a residential building. Meters are of two basic types for different voltage and amperage ranges. So some sub-assemblies are sold separately for repair or for changeovers. The problem is determining a production schedule to identify each item, the period it is needed, and the appropriate quantities. Right? So the schedule is then checked for feasibility, and the schedule is modified if necessary. All right, now then we come to the important information. It's here. It says each product A requires one part C and one part D. All right. So product A. So basically, this is the final product. Okay, A requires one C and one D. So basically, we can start to draw a little bit about the tree, right? One C and one D. Okay, and each part C requires two parts D, which requires two parts D, right? And each product B requires one part C. B is not in this part, so we have to start a new one. Each B requires one part C. One part C, right? So this is a simple general product tree. We draw based on information. All right. Then now let's look at the next paragraph. It says for A, B, C, D, there are 50, 60, 40, and 200 parts on hand, respectively. We already have those parts, right, with certain numbers. And their lead times are 2 to 11 weeks. And part C needs to have 5 parts as safety stock. Okay, part C needs to have 5 parts as safety stock. And part D requires 20 safety stock. Right, part D requires 20 safety stock. Currently, there is a scheduled receipt of 10 units of part B in week 5 and 100 units of part D in week 4. And for A and B, order quantity is lot for lot. And for C and D, order quantity is 2,000 and 5,000 respectively. All right. I need to explain some terms here. So one is lot for lot. So lot for lot means I only order what is needed, right? If I only need 20, I'll order 20. If I only need 21, I'll order 21. If I only need say 335, I only order 335. So that's lot for lot. And if it is order quantity of 2,500, 5,000, what it means is every time I place an order is a fixed quantity. Remember our fixed quantity model, right? Fixed quantity. So even though I only need one part, right? Even though I only need one C or D, right? I have to order 2,000 and 5,000, right? If I only need one C, I have to order 2,000. If I only need 1,999, I order 2,000. If I only need 1,000, I need 2,000. All the same. If I need 2,000, I need order 2,000. Same with D. Even though I only need one D, I still need to order 5,000 parts. All right. So this is how it works with fixed order quantity. Well, another term is scheduled receipt. So scheduled receipt means it's something you have ordered before in the past, or you have made in the past that will be arriving at a certain time, at a scheduled time, right? So here it says there's a scheduled receipt of 10 units of B in week 5. So this means that in week 5, 10 units of week B, 10 units of part B will be here, right? Will be here. It's not from the order that I made today. It's from the order something maybe from the past, right? That's not within our scope, but it just counts, right? Think about this as a lucky money, right? As a lucky money, it suddenly arrives. Schedule receipt. But usually what happens with scheduled receipt is that the company or some production system, they might order some extra, or they have already ordered something in the past that they will foresee that they might need. But not really just to fill the one certain order, or sometimes they work on some Kanban parts and they just want to make some extra parts for buffering. So this is this kind of situations that might create this kind of scheduled receipt. All right, we understand what is safety stock. So in this case, safety stock means you always have to reserve some of the parts that is not within your planning, right? That's not part of the planning. Say part C needs to have 5 parts as safety stock. So these 5 parts should not be within your planning, right? Always sitting there, right? They can only be used when it's really needed. But in our planning, we should minus this 5. Same with D. In our planning, we should just ignore this 20, right? Means if we say we have 300 of D in stock, but actually what we can use in our planning is only 280, right? So 300 minus 20 is 280. We can only use 280 for our planning. All right, so this is what it means with different terms. Now let's look at next. First thing we need to do is to construct a product tree. So for the product tree, I already constructed, but usually when we are composing a product tree, we want to make sure it's low-level coded, right? Low-level coded. If you remember the product tree I composed here, you can see so low-level coded tree means all the same parts should be at the same level, right? C at the same level. D is different. So D here it's level, let's say level 1, level 2, level 0, level 1, level 2. But this D is in level 1, this D level 2. So in order to convert it into a low-level coded tree, we need to move this D down to level 2. So that's why we got this product tree, right? Move this D down to level 2. Same here. B is composed of one C, and each C actually composed of 2 Ds. So this is what I'm talking about. Remember here, right? You also need to add 2 Ds here, right? Do not, because this is not the low. C is not the lowest level of parts, right? C is not the lowest level of the parts. We need to make sure we get all the lowest level of the parts in our product tree. So that's why we have 2 Ds here. So this is how we construct the low-level coded product tree. This is very important because when we are composing our MRP table or working on our MRP table, the demands are all based on this product tree, right? The demands are all based on the product tree. I will use this example to show it. Why is it? All right, so before we come to this big table, now I want to explain a little bit about what is this table is composed of. But basically, this table is composed of 2 axes. So the horizontal axis and also the vertical axis. So horizontal axis is the time axis. You can see this week 1, 2, 3, 4, 5, 6, 7, 9, 10, right? And it can be weeks, it can be hours, it can be days, or it can be months or years. It really depends on what time frame you are doing this kind of MRP planning, right? Another unit model is this. This is one unit model we're gonna look at. So basically, it looks like one single item, and these are all the information about one single item, right? So OH means on hand, LT means the lead time, and SS means safety stock, and Q means the order quantity, right? We can get a detailed information from this table, okay? First, we need to write which item we are talking about, right? We write this item here, and then what is the order quantity? 200. What is the lead time? Right, lead time is 1 week or 2 weeks. Based on what kind of time frame it is, and also on-hand inventory means at time zero. So at time zero, at the time we haven't started to do this planning yet, how many parts of this item do we have on hand right now? Right? How many parts do we have on hand right now? So this is the on-hand inventory. And safety stock means how much safety stock do I want to keep for our planning. All right. So next, let's look at this column items. This column means the first means gross requirement. So gross requirement means at a certain time, what is required? What is the quantity of the required quantity for this model, for this item? For example, week 4. So week 4, I need 45 VH1 234s, right? I need this amount. And week 6, I need 48 this parts. And week 8, I have 48 this part, right? The next one is scheduled receipts. I mentioned about scheduled receipt means it's something like lucky money, right? Only when we are composing this MRP, but it's actually ordered prior time. It's not just within this weeks. It's from prior time. All right. So currently there's no scheduled receipt for this part. But if there is a scheduled receipt, say suppose we have a scheduled receipt. Here, say 10 units, right? So what happens is that the projected available balance is what is the available balance at the end of this week, right? At the end of this week, right? If there's no scheduled receipt, at the beginning we have 85, right? We have 85. Then gross requirement is 34. So means I need to fill a requirement of 34. So the projected available balance after this week or at the end of this week will be 85 minus 34, which is 51. Right? It's 51. Now suppose we have scheduled receipt, right? Means what? Suppose we have scheduled receipt. Okay. Now at the beginning of the week I have 85 units. The gross requirement is 34. And scheduled receipt is 10. Then projected available balance will be 85 minus 34 plus 10, right? Then this will be 61 instead of 51. So this is how the scheduled receipt works, and it's how do we compose this gross requirement, scheduled receipt, and also projected available balance. Okay. All right. So next, net requirement. Next item is the net requirement. So the net requirement means how many parts we still need, right? How many parts we still need in order to fill the order. So usually when it only has a number when we cannot fill the gross requirement at the beginning of the week. We have to get some more parts, or order some more parts from prior time. For example, here, right? In week 3. What happens in week 3 is at the end of week 2 or at the beginning of week 3, we only have 14 parts, right? Say at the end of week 2 or that beginning of week 3 at the same time, right? We only have 14 parts. All right, the requirement for week 3 is 41. I only have 14, but it needs 41. What should I do? Then I need to make sure that I order some. Right? I need to order some parts, these parts that we want these order parts arrive, right? Arrive in week 3. Then we can fill this order. Otherwise, if it arrive early, if it arrive early, it's fine. But we want them to arrive too early because it will increase our inventory fees. So you really want to have them to arrive in the same week. If it arrive late, we cannot fill the order either, right? So we have to let them arrive in the same week. All right, how do we do that, right? So we have 14, and the requirement is 41. So the net requirement is actually 27. So we write a 27 here. Write a 27 here. Right? Write a 27 here. All right, we need a 27. We know we need 27 parts. Then what should I do? I should make sure that order these 27 parts early, right? I need to make sure that order these parts early. So now let's look at this item. Let's see this order quantity. Okay, I know I need 27, but order quantity is 200. Means what? Means regardless how many parts, is 27 or 1 or 199 or 200, as long as it is less than or equal to 200, I have to order exact the same number as 200 here, right? Because the lead time is 1, so that's why I need to order at week 2, because the lead time is 1. And this 200 will arrive, right? So that's a planned order receipts. And this is a planned order release. This planned order release, and this arrives, right? Same here, you can see, and this arrive 200, right? This planned order release means I placed the order, how many parts I gonna order, and then planned order receipt means how many parts actually arrived, right? We received. All right. So in week 3, now we know, okay, at the beginning of the week I have 14. The planned order receipts is 200, right? 200. And the net requirement of what? Net requirements is 27. Net requirement is 27. So in this case, so basically we just use 200 minus 100, minus 27. We get 173. Minus 73. Okay. Right? Or on the other hand, another way we can calculate this is 14, we have this at the end or beginning of the week, then we order 200, right? Or receipt in week 3, I use 14 plus 200, and then minus the gross requirement, 41. Gross requirement 41 to get 173. Right? So basically, this is how we go through this, this table. And the big table here is actually composed of many different parts, right? It can be part A, or B, or C, D, E, F, right? And for each one, we can compose all these numbers, right? For each one, compose these numbers. Of course, some of them sometimes will require more other parts here. So basically, this is how this table, what is the layout of this table, and what should we need to do in order to generate the demands. All right, now so let's use this example to demonstrate how do we compose this entire table. Because we already composed the product tree, right? We also have the information. So what you can do right now is to get the exercise sheet next to you, because you need to read through the problem statement, right? We need to go through problem statement with sentence by sentence, and then start to work on this table. All right, I have the problem statement on hand right now, and I'm gonna go through it. I'll start from the from the product tree here. So we have the table, and first thing we need to know is we need to determine the sequence of the table. Okay, the sequence of the table. Remember, the sequence of the table should always be from high level to low level. Right? So high level to low level. Now in our case, the highest level is what? It's A, right? And then it's B, and then it's C, and then it's D. So in this case, I'm gonna put item A here, item B here, item C here, and then D here, right? I provided some extra lines or extra rows. I do not need so many, but if the product has more items, then we can complete all of those. All right. Just keep in mind that it's not always A, B, C, D, E, F, G, right? It should be based on the level of the product tree, always from high level to low level. Why is it? Because, think about this, because the requirement of A, right, can always determine the requirement of C. In other words, the requirement C is dependent on the requirement of A. Same, the requirement of D is dependent on the requirement of C. Right? So only when I know what is the requirement of C can I know what is the requirement of D. Only when I know the product, the demand of A, can I know what is how many do I need for C and how many do I need for D. Right? So that's why the sequence for the items should always be from highest level to the lowest level. Okay. All right. Now let's come back. This again. A, B, C, and D. We got this. Okay. Now let's continue. We already got the product tree. Then let's look at all these other informations in this problem. So for A, B, C, D, there are 50, 60, 40, and 200 parts on hand respectively. So now the OH means on hand. Okay. We need to first fill out the information of what's happening with this product A, with this item A. So item A on hand is 50. 50, okay, and the B is 60, C is 40, and D is 200. So we write it down here. Okay, and then it says the lead times are 2 to 1 weeks. Right, so lead time for A is 2 weeks. Write it here. B lead time is 2 weeks. And C lead time is 1 week, and D lead time is 1 week. So this is basic information about each of the items. Right? Continue. It says part C needs to have 5 parts as safety stock, and part D requires 20 safety stock. All right, part C safety stock is 5, and part D safety stock is 20. Okay. Then currently there is scheduled receipt of 10 units of part B in week 5. All right, now part B, week 5, right? Part B, week 5. We find the scheduled receipts, part B, week 5, which is 10 units. So we need to write a 10 units here. Make sure we don't miss this information. It's very important information, okay? And 100 units of part D in week 4. Okay, week 4, part D, 100. Scheduled receipts, 100. Okay, I'll write it here. All right. Now we're good. And then for A and B, order quantity is lot for lot. So A and B order quantity, which is Q, is lot for lot. Sorry, it's lot for lot. B is also lot for lot, which means we only need to order the same quantity as we needed, right? And for C and D, order quantity is 2,000 and 5,000. For C and D, C, 2,000. And D is 2,000. Okay? D is 2,000. And next, in week 9, we need 1,250 units of part A. So part A, week 9, gross requirement is 1,250. We need to write it down here. And 470 units of part B. Part B, week 9, okay? Part B, week 9, 470. Week 9, Part B, 470. And 270 units Part D. Part D, 270. Okay? Then they asked us to develop a material requirement planning schedule. All right. So basically, what we have, the table we have right now is based on the problem statement. All the information we know the basic setups for A and B and C and D, like order quantity, the safety stocks, the lead time, and on hand. Same for B and C and D, and also we know all the schedule receipts, all the requirements are here. Now let's work on this table. Okay. All right, start from very top level, right? From the very first part, part A. All right, for item A, now let's look at week 1. We know week 1, currently what happens with week 1 is there's no gross requirement, right? There's no gross requirement. There's only a gross requirement in what? In week 9, 1250 in week 9. So which means what? Which means that the on hand or the projected available balance at week 1, at the end of week 1 is what? Is 50. Because there's no requirement, we have this inventory, on hand inventory, we are not using it, and at the end of week 1 is 50. Same thing, 50 week 2. No demands. We do not have to fill out any orders. These 50 are always there. Same thing week 3. Same thing week 4. Same thing week 5, week 6, week 7, week 8. All right, now week 9. So what happens with week 9 is, all right, at the end of week 8 or at the beginning of week 9, I only have 50 units of A, but requirement is 1250. 1250 means what? Means we are short of 1200 units, right? We are short of 1200 units. Yeah, do you understand? All right. At the end of week 8 or at the beginning of week 9, I only have 50 units because this is what we have, right? But the requirement in week 9 is 1250. Means in week 9 I need to fill the requirement of 1250 units, but I only have 50. Okay, I'm short of 1200. So the short of 1200 means that's the net requirement. So that's the net requirement. That's why I write 1200 here. Means I'm short of 1200. Okay, I'm short of 1200. What should I do next? Well, I need to order it. Before week 9. So the enough parts will arrive in week 9. All right. Then when should I order? Let's look at the lead time for A. Lead time for A is 2 weeks. And the quantity for A is lot for lot. Means I only need to order the same quantity as needed, right? There's no fixed order quantity, right? It's lot for lot. If I only need 1, I only need to order 1. If I need 2, I only order 2. If I need 1200, I only need to order 1200. Okay? So it means I'm short of 1200, I only need to order 1200. When do I need to order it? I need to order it at week 7. So why week 7? Because the lead time is 2 weeks. So we write it down this 1200 at what? Plan order release. Plan order release. That's why we write here 1200 plan order release. 2 weeks before week 9, week 7, plan order release. Right? We order 1200. And then what happens, this 1200 will arrive in week 9. 1200. Right? 1200. They will arrive at week 9. This is a plan order receipts. This is plan order receipts. Plan order receipts, plan order release. Okay. All right. So remember, every time when you are planning an order or when you are having this planned order release, one important thing we need to do is go back to the product tree. Go back to the product tree. Okay, let's go back to the product tree. Let's see what. If I need 1,200, if I place an order of 1,200 units of A, what happens is that I will need more parts for C and D's, right? I also need more parts for C and D's. So which means I will also need 1,200 C's and also 1,200 D's. I'm not talking about this D here right now, because this D is not directly related to A. It's not directly related to A. I only look at when I'm placing the order of 1,200, 1,200 A. I only look at what are the direct needs. What are direct needs from direct needs for closely related to A. That's the C and the D, right? In terms of this D, the final D, how many is needed, eventually we'll figure out what is the C, right? Because I don't know how many C do I need yet, right? Eventually I don't know how many C do I need because I haven't finished my table yet, right? Currently I know it's 1,200, maybe it's 1,200, maybe it's 1,600, maybe more. But right now I don't know. I only know this kind of D I will need only when I already know the final number of C. But right now I can only determine what is direct needed for this order. Right? So that's why we only look at the directly related to A, which is this C and this D, 1,200. All right. So when I need 1A, I will also need 1C and 1D. When I need 1,200 A, I also need 1,200 C and 1,200 D. So which means that when we come back to this table, we place an order of release of 1,200 A. I also need to put the 1,200 as C, right? 1,200 as C, and also 1,200 at D. So this is why. So every time we place an order or have a planned order release, we need to go back to the product tree and look at what are the other parts that needed or are triggered, right? It has to be immediate or direct related to A, right? So this is 1,200. This step is very important because once you miss this, if you miss this 1,200, miss this 1,200, all the other numbers will mess up, right? So that's why remember every time we place an order, you go back to product tree and then check what are the requirements generated, and then write it down on this table, right? Before what? Before you figure out what is the projected available balance of A. Right now, I place the orders. I generate the new requirements. Now let's go back to this item A and week 9. All right. At the beginning of the week, I have 50. Right. And then I'm short of 1,200. But I order 1,200, which means that at the end of this week, we have 0. Right, because I order enough to fill out this gap. Right, fill out this net requirement. 0. So that's 0. Same thing for week 10, because there's no requirement. I just inventory or this the balance will be 0. Okay, 0 again. Now we finished A. Okay, so basically it's after we finish A, you probably already understand the logic. How do we compose this MRP table? Now, in order to give you a better idea, I'll work on this throughout the whole table. So just follow me on this logic. Next, let's look at B. Okay, let's look at B. So what happens with B is that B, the on hand is 60, right? At week 1, there's no requirement, right? There's no requirement. So the on hand or the projected available balance for B will be will be what? Will be 60. Right? This will be 60, 60, 60. Okay? Until week 5. So week 5, we have a scheduled receipts, which means, all right, I get 10 more. I have 10 scheduled receipts. The projected available balance will be 60 plus 10 because on week 5, there's no demand, right? There's no requirement. We do not need to fill any order. So there will be 6 plus 10, which is 70. Right? At the beginning of week 5, I have 60. Well, in week 5, we got some lucky parts, right? It's 10. Then we got 70. Week 6, 70, because no requirement. 7, 70, no requirements. 8, 70, no requirements. Okay? And how about 9? 9, at the beginning of the week 9, I have 70. Okay? The net requirement is 470, which means I'm short of, or the net requirement will be 400. 470 minus 70, right? I'm short of 400. And what do? We place the order. Remember, place the order, right? When do we place the order? We look at the lead time and also what is the quantity? It's lot for lot. So which means I only need to order 400. It's 2 weeks, so which means that I will release our order 2 weeks before week 9, which is here. 400. Okay. 400. Now, because we are doing some planned order releases. We are placing some orders for what? For B. What we do now is go back to the product tree. Right? Remember, for each B, we need 1 C. We only look at the direct relation. We do not look at this, right? We only look at direct relation. For each B, we need 1 C, which means that in this table, we need 400 of B, means it triggered another 400 for C, right? It triggered another 400, which means here it should be 1200 plus 400 will be 1600. Now let's modify this. 1600. So be 1200. Change another color. 1200 plus 400. Plus 400. Right? All right. Now, because C is only directly related to B, so that's why it only trigger one requirement, right? For C, that is 400. All right. We did this requirement part, and then let's go back to this B. So B, we placed an order at week 7 of 400. And this 400 will arrive after the lead time, which is here, right? Here, 400. And we got 400, and the net requirement for this week is 400, so this is 0. Week 10 also 0, because we do not have any on hand anymore, right? And also there's no net requirement. We do not need to place any orders anymore. Okay. All right, so this is how we compose this this B. Now let's look at C. All right, for C, what happens is week 1, because we have on hand of 40 and there's no requirement, so this projected available balance in week 1 at the end of week 1 will be 40. Same thing here. Let's carry this amount of items until week 7. Okay. Oh, sorry. I forgot one thing. That is very important here. That is not 40. It's actually 35. Why is 35? Because it has a safety stock, right? We're a safety stock. So safety stock means we already reserved this for safety stock. It should not be part of our planning. It should never be part of our planning. And we are doing this MRP table means we are doing planning. So we should not count this 5. So that's why it should be 35 here. It should be 35, not 40. 35. Until week 7. So week 7, now we know it would need 1600 in week 7, right? Now we are short of what? We are short of 1565. We only have 35. We need 1600. We are short of 1565. That's the net requirement. And what do? We place orders, right? We place orders, buy them. All right, place orders, and then we look at lead time. The lead time is 1 week, which means we need to place the order, excuse me, at week 6. So let's plan an order release at week 6. And how many should I place order? We should order, it's a fixed quantity, which is 2,000. Means even though I only need 1, I still need to order 2,000. But now I need 1565, means I need to order 2,000, right? 2,000 here. Means I need to order 2,000. All right. Remember, every time we place the order, we go back and look at the product tree, right? We go back and look at the product tree. And we look at the product tree, we know that for each C, it requires 1 D, right? For each C, it requires 1 D. So now means I already placed 2,000 requirement for C here. Then I need to put 2,000 of D here at the same week, because we want this 2,000 D arrive here, same week. All right, now we place the order, and this order will arrive next week, right? At week 7, 2,000. Now we are short of 1565. I order 2,000. What's next? Next, after I fill out this net requirement, I still have 435 left, right? I still have 435 units left, right? Now we're gonna carry this 435 units to week 8. Now let's look at, do I have gross requirements for week 8? No. So that's why I'm gonna carry this 435, because there's no gross requirements in the next few weeks. All right. All right, it looks like I made a little mistake here. So this is not 2,000, it actually should be 4,000. So the reason it's 4,000 is because in our product tree is for each C we actually requires 2 Ds. For each C it requires 2 Ds. So this is the 4,000. Yeah, remember our product tree here is for each C it requires 2 Ds. 4,000. All right, now let's look at this D. So for D, and same thing. Let's start from week 1. On hand is 200. Safety stock is 20. So which means there's only 180 available, right? Balance 180, no requirements until week 4. Because we have scheduled receipts, we add 180, we'll add another 100, so we got 280 right by the end of this week. There's no requirements, so 280. until week 6. So week 6, right? Week 6, at the beginning of the week 6, I only have 280. Well, the requirement is 4,000, which means I'm short of what? 3,720. 3,720. All right, we know we are short of this amount. Then what should we do? Is we need to order, right? We need to order. So, and now we look at the quantity and look at the lead time. So the lead time is 1, which means that I need to order at week 5, right? We need to order at week 5, which is here, and the quantity 2,000. So we have to order in 2,000, right? Because we only need 3,700, 200. So which means we need to order multiples of 2,000. How many 2,000 do I need to order? 2, right? 4,000 is enough. So is it 2,000 or 5,000? It should be 5,000 the quantity, I think, right? It's in order quantities. Oh, it should be order quantity is 5,000 for D. 5,000 for D. So you can see it's really easy to make mistakes. This is 5,000. Okay. Well, if it is 5,000 in this case, it becomes similar because we need 3,720. Then in this case, I just need to order 5,000, right? But if the order quantity is 2,000, then we have to order 2,000s, right? 4,000, and then to fill the order. Okay. So because it's only and also we put it the wrong place here, because it's the lead time is only 1 week. So 1 week lead time, order release should be here. Okay, and then this 5,000 arrives here. 5,000 arrive here, and then fill this order. Then we get 1280 here. 1280. Okay. All right, so we have 1280 at the end of week 6. Now comes to week 7. So week 7, what happens here? Okay, at the beginning of week 7, I have 1280 parts. Then in week 7, I need to fill the requirement of 1200. Right? I have 1280. I need to fill 1200. Means I have enough materials. Right? If I have enough materials, I just need to use 1280 minus 1200. We got 80 left. So after I fill out the requirements, I still got 80 left. I do not need to order any new parts because I have enough materials. All right, and then same thing. Because there's no requirement for week 8, I just carry the same amount to week 8. Then week 9, constantly, because we are short of 190, I need to order 5,000 here. 5,000 here, and then 5,000 gonna arrive, and then minus this 190, we got 4,810. Right? No requirements here. 4,810. So someone notice when I'm generating this requirement, why didn't I go back to the product tree and then generate some other orders? Because D is already at the lowest level, so I do not need to, because no other parts are composed of composing D, right? D cannot be decomposed into other parts. So that's why D is already at the lowest level. I just need to place the order. I don't have to go back to the product tree. But if the part is not at the lowest level, then you always have to go back to product tree and look at what other demands or requirements are generated. Okay? All right, so this is how you compose this MRP table. You can see for each of the week, you know how many parts do you need, right? Do you need to prepare? How many parts do you have for each of the items? So this is how you plan out the production of materials or the material requirement. All right, so this is how you do this MRP. Now let's look at ERP. So we know MRP is material resource planning, while ERP is enterprise resource planning. So MRP is mostly looking at the raw materials or the parts that are required for the production shop floor, but the ERP is mostly for looking at the whole enterprise, because enterprise has a lot more other functions than production itself, because it also have logistics, it has supply chain, it has sales, marketing, finance, human resource, a lot of other functions. So think about the ERP as our medicine. Right, you pay tuition through my medicine. You register classes. You can do a lot of other things related to my medicine. So it's the same thing in production companies. They also need a software to coordinate all the information so everyone can access to the same information and easily, and also make decisions and control it. Right, so and there are some typical vendors for popular vendors for ERP softwares. SAP is very popular one. A lot of companies use SAP, and you can do a little bit of research about SAP and learn a bit more about it. And also some other vendors will be like Microsoft, Oracle, and some other companies. So some other thing, why do we need ERP, right? So ERP is a centralized system. A centralized system is compared with a decentralized system. So decentralized system means information is conveyed, is transferred only between the functions, right? For example, sales gonna communicate with inventory. Say, hey, I need so many these kind of parts. Do you have those? Then inventory gonna talk to HR. I don't have enough people to help me out. Or then inventory probably gonna talk to the production shop floor. Say, hey, what do we do? And then so you can see all these communications are only between two of them, right? There's never a information hub that all the different functions can get access to. Means the information is not shared. There's inconsistency of information in this. So that's why these decentralized system usually have this kind of issue. And in order to solve this issue, people develop this ERP system that if I need something, I just post it in the system, and then everyone can get access to that information. So everyone knows we are all on the same page of the same information. So that's why centralized system gonna help out, make it more efficient for dealing with these issues. All right, now let's look at what are the different functions or the scope of ERP applications. So ERP really has a lot of different functions. It can do human resource management, finance, sales, marketing. And also, we generate some measurements of the performance of the system, and all the data warehousing, inventory controls, report generating, and also transaction processing. You can all doing that on the in the ERP system. Of course, manufacturing and logistics are always part of the ERP system. All right, so that's about MRP and ERP. So basically, you need to understand what is MRP and ERP, and know what is the logic of MRP by composing the MRP table. So most important part is if you know how to compose the MRP table, basically you understand what is MRP. All right, next I want to talk a little bit about supply chain management. So supply chain management is a really big topic. You probably need the whole course to discuss this issue, but I only use a few minutes to go through what is covered. And if you're more interested in this, probably you can take courses or do a little more research on this topic by yourself. All right, so what is supply chain management? So supply chain management basically, in a simple word, will be the management of chain of supplies, right? Look at this, beer management or beer life cycle supplies. Well, the beer already started from the farm, right? Then we got hoppers, we got grains, and then we need to make sure in order to make enough of the beer in different bottles, we need to have a can, right? Can manufacturers to work here, and so for can manufacturers, they make cans, but they also will need some raw materials like aluminum, right? So there are some different suppliers for the aluminum for the can manufacturer to make those cans. Same with the bottles, the same thing. If you need those bottles, you need to get some glass or some other materials. So those bottle manufacturing, and then while the brewer, right? Brewer, what they do is, they make those beers, and they also need to get enough, cans and bottles so they can bottle them, right? And then after that, they will send it to the distributor who gonna, sell them to the groceries, and then eventually the customer gonna buy them, and then drink them. So basically, this is how how the supply works. You can see it's never about, this whole supply chain is never about one single participant. It's really gonna be a lot of other participants involved in it, right? So if one participant got some problem, for example, can manufacturer cannot make enough cans, then will affect the brewer as well, because they probably not have enough containers to get those beers. Then distributor will not have enough beers to be made, right? And then the grocery store will be short of beers, and then you probably won't be able to buy beers, or the beer price will probably gonna go up, right? So we can see how something happened at one part of the supply chain gonna affect all the other parts. All right. So the bullwhip effect is kind of a talk about effect, so along the supply chain, and how that exaggerates, over from one participant to another along the chain. And usually it starts from the forecast. For example, if the forecast says that the customer needs a little bit, demand are actually increasing a little bit, but when it comes to retail, they're probably gonna exaggerate that this kind of increase by a little bit more. Consequently, the wholesale, right, will also gonna start to exaggerate more about the retail one, right? And and see what happens about this forecast. And then when it comes to the manufacturer, that this kind of exaggeration it becomes even bigger. So what's the result of this will be manufacturer gonna produce a lot, too much, but the customer demand is actually only increased a little bit. So this is how the bullwhip effect works. So basically, it shows that the effect that happen on one part of the supply chain will always be getting higher magnitude than the other participants. So one game to understand this bullwhip effect is the beer game. You probably have played it in 211, or you probably have played this in some other classes. But this beer game is a very good game to learn what is the bullwhip effect in supply chain management. All right, so in supply chain management, there's also there'll be different topics. And the one topic is about purchasing. So when we are doing purchasing, you have to think about many different factors that are gonna affect purchasing. For example, your cost, right, the quality, the delivery speed, the supplier flexibility. For example, if you only get purchase from one single supplier, then you have to bear the risk that if that supplier it cannot supply you anymore, or the lead time, or the lead time varies a lot, or this it got some issues, they cannot work with you anymore. In this case, you have to think about how do you deal with those kind of situations, and that's all the risk. A lot of times, if possible, people would like to purchase from multiple suppliers, so to reduce this kind of risk. But make sure you also need to balance all the other factors: cost, quality, delivery speed, flexibility. And purchasing decisions is usually not made by one single person. It's actually corporate purchasing. It's a department issue. Also, you need a lot of relationship, negotiation, and analytical skills, right? So, for example, in for say Nike, right? So if Nike is making shoes, and then they will first they're probably gonna monitor the suppliers, look at their factories, that how their products are made, what is the situation with the factories. It is a black factory or some ethical issues or some other part, quality related issues. They probably gonna send some representatives to those factories and to monitor everything is good in condition, or they're probably gonna do some auditing of those factories in order to make sure that it's they're in good quality and quantity. So that's one way you can work with your suppliers. But those kind of things always happen in large enterprises. It is a small company. You probably can figure out some other ways to make sure that you always have good quality of the products, or materials from the suppliers. And for the manufacturing of our operation, so this is the most important part in your own company, because these are all the operations. In management, there's a triangle, is time, cost, quality. Time, cost, quality. You always have to think of how to balance the three in order to generate a better performance. These three items are related, and for example, if you spend more time, you're probably going to increase the quality, but you're probably going to generate more. Gonna cost you more, right? If you decrease the quality, then it probably going to cost you less. Then the problem is you got some quality issues. So the decisions are always around this kind of triangle. Then you have to, as a manager, you have to think about how do you balance those three metrics in order to make a better decision. Next is the transportation logistics. So when you are shipping or transporting your products to your customers or distributors, then you have to think about what the transportation method is the best way. You want to save money, right? Save time, and also make sure it's safe, right? So truck, rail, aircraft, ship, they all have their own advantages and also have their weaknesses. Then still you have to find out what is the best way to transport those. And it depends on the customer's demand and also your own cost, right? And safety. Well, for the logistics, you during the shipping and the transportation, you have to think if you have some product that is really sensitive to the environment, you probably have to think about how you store them or how you package them to make sure that the quality won't get bad. And also, if you are exporting it to some other countries, then you have to look at the some regulations, laws, and taxes, insurance, and all the different things. That's all you have to consider if you are a supply chain manager and you're doing logistics. And for the retails, you also have to consider about your at the retail end. You also have to consider about how your products actually compete in the market, right? You might want to look at your competitors' products and then look at the differences and the pro and the cons, and try to find out where do you want to stand in your market, and also how do you want to improve your product in order to be better, higher, have a higher competitiveness. So you need to understand that business is actually changing day by day, and your mind and your mindset, your decisions also need to be always be dynamic, right? Based on what is happening today, and then with the plan for tomorrow, or even longer time frame. So material, money, and information, these are the key informations in supply chain management you have to think about. And so global supply chain management, so currently you can see a lot of factories, or companies, they move to a different location or different country just to get either a cheaper cost, labor, or some other benefits from taxes or something else. But when you are relocating those facilities, or you are doing some having this global supply chain, you might want to think about a lot of other factors, because usually those cultural differences, the local laws and regulations probably gonna also play a big part in your decision making, right? Lastly, the social responsibility. So when you're supply chain management, so you also have to think about what are the social corporate social responsibility you are taking in your company. Like if your material suppliers have some ethical issues, child labor. If your own companies are doing this, right, that's really bad. But a lot of times you probably have to monitor what is our suppliers doing. Then, for example, Apple, right? Many years ago, they said that Apple have some got some phones are made from the blood factories, or some from child laborers, and then consumers buy those news. They think those kind of products are actually made from those really bad environments factories. Then they stop buying those kind of products. So same, if you are the manager of supply chain management, manager of your company, then you have to think about those ethical issues, because it's probably gonna eventually gonna affect your sales. And sustainability. So sustainability is really now becoming more important, and many companies are starting to embed sustainability practices and their own activities in order to increase the visibility of their behaviors. For example, a lot of companies release a sustainability report every year, so you can see how do they do in order to protect the environment, in order to do more social, take more social responsibility, something like that, right? Community interactions. So if your company is located in a certain community, you might also want to think about how do you get the local community involved, or by hiring local laborers, right? Local employees. We have a big company, Merck here, right? So during their expansion, they also talk a lot about community interactions. How do they want to provide more opportunities for JMU students, maybe have more interns here, or what other benefits that local community and the universities or schools can have by investing more in Merck, in Harrisburg. All right, in terms of the performance measurement, it's really, there are going to be a lot of metrics you develop. It's never a set of metrics you have to use. Never a set of metrics that's only metrics to measure your company's effort. Instead, you have to develop a trustable metrics that based on your company's situation, right? And of course going to involve both the customers and suppliers, and also requires a lot of data collection, and then start to evaluate what is performance in terms of time, cost, quality of your supply chain management. So when we're talking about quality, so quality management is another bigger issue. You can have supplier evaluation, quality management embedded in supplier selection. When you are selecting the suppliers, you also need to want to know what are their qualities, if they are meet our standard or exceed our standard, and all these qualification testings. Also, how these quality managers are embedded in production processes. So in the next lecture, I'm going to talk about more about quality control in production companies. Then we'll discuss process improvements in Lean Six Sigma, and also what are the different programs related to quality management. All right, so that's all about supply chain management. So basically, you need to understand what is the supply chain management, the considerations in the purchasing, transportation, logistics, in the retail side, the global supply chains considerations, and also how do you measure performance in supply chain management. That's all for today.